All right, guys, we're in lesson 19 of our Algebra 2, or Saxon Algebra 2. We're talking about valued word problems and AA equals AAA, or your book titles it AA means AAA. We'll see what that means in just a little bit. But let's talk about valued word problems before. We've seen word problems, and we've seen problems where we had to set up system of equations before, but we're diving into something new, and that's valued word problems. Remember, we talked about subscripts as well and what they're going to do for us, and we may not have understood the subscripts at the time, but we're going to see where they play a role in this lesson. And so we'll really talk about I tell you what, let's just jump into the first problem, and then we'll explain as we go along. That may help a little bit. 19.1 says this: Karamagu had 50 nickels and dimes, whose value was $4. How many of each kind of coin did she have? Okay, so she had 50 nickels and dimes. And so instead of just using X and Y, we use NN and ND for the number of nickels, the number of dimes. And you can see the reason we're going to do that, because here in a minute, we're going to talk about how much they had. And I just realized I messed up something here. Let me finish my 4. We're going to see how much they're worth and not just how many they have. Now, nickels plus dimes is 50. That's how many pieces of coins they had. They had some amount of nickels and some amount of dimes, and together there were 50 coins. We understand that. But this is where it gets important to label the number of nickels and the number of dimes, because nickels are worth 5, dimes are worth 10. I know we know that, but we had a total of, well, our book says $4. But here's the way we do this. Instead of putting 0.05 and 0.10 and putting 4, we change everything to cents. So there's nickels are worth 5 cents, dimes are worth 10 cents, and $4 then becomes 400. And so doing this allows us to not have to worry about decimals. Okay, we don't really want to do that. Okay, so just recall that whenever we talk about the value, or that one equation that talks about the value, before the number, you have to put what that coin is worth. And we'll see some other things as well on our next problem. But let's go ahead and work this out. As we do, remember our first step says we need to see if there's a matching number. And that would be deciding if, eliminating a number. And that would be deciding if we can match a number or an opposite sign. We don't have that. And I think our book actually uses substitution. I'm not going to do that. I'm going to use elimination, just because I like elimination a whole lot better than I do substitution. So I'm going to multiply everything up here by -5. If you want to do substitution, by all means you can do that. It's not going to hurt anything, but then you'll just need to follow your book, and your book can show you that substitution. But I want to show you the opposite way, and I'm going to multiply this by -5, this by -5, and this by -5. That 50 becomes a -250. Okay, so you see what happens is the ends are now canceled, they're gone. And then we have the number of dimes, 10 minus 5, of course there's 5 number of dimes, equals, well, 400 minus 250 is 150. And then once we get that, we can just divide by 5 on both sides and say our dimes equal 30. And if our dimes equal 30, we can go back to one of our original equations, which said the number of nickels plus the number of dimes equaled 50. And if the dimes were 30, well, then the number of nickels would have to be 20. We would just take this 30 over here, change sides, change signs. So number of nickels equals 20. And hopefully you caught that and understood that. Again, I like the elimination a lot better than do substitution. It just works better for me. Let's look at the next one. The book reads, let me read it to you. The fishmonger sold codfish for 6 pence each and mussels for 1 pence each. If Harriet bought a total of 26 items and spent 86 pence, how many codfish did she buy? Okay, so we don't have dimes or nickels or anything like that, but we do have the number of codfish, the number of mussels. Is that what we said? Mussels were 26. That's how many she bought. Then they told us how much each one of them cost. The codfish were 6 pence, the mussels were 1 pence, and she spent 86 total. See, this is the value portion. And that's why we use these subscripted variables. Okay, so let's go ahead and do this. Now we're going to look and see if there is opposite signs. No. Is there a same number in one of them? Yeah, right here there is. I know there's no number here, but it's understood to be 1. This is 1. And so what we're going to do is change the signs up here. You say, can you legally do that in algebra? Yeah, you can. In an equation, you can change every sign in the equation and not hurt the equation. And so once we do that, we see the number of muscles cancels. 6 minus 1 is 5. That's the number of codfish. Equals, what's 86 minus 26? Well, it's going to be 60 divided by 5 on both sides. The number of codfish equals 12. So if the number of codfish were 12, what does that leave our number of mussels to be? Well, we had a total of 26, and so you can figure that out. The number of mussels was going to be 14. Okay, and so pretty easily understood, I hope. If you didn't, if there's some mix up a little bit there, just remember, whenever you talk about a value, you need to put a number in front of the equation that has the values of what they're worth. Codfish cost 6, mussels cost 1. Up here, nickels were 5, dimes were 10. All right. Okay, so if you have any questions about that, we'll help you out, and feel free to comment or ask questions, or for a clarification, we'll make another video clarify that or some more problems. Okay, we're going to move on to AA means AAA. That doesn't make a whole lot of sense probably if you're not familiar with geometry, but the AA stands for angle, angle, and then if you have AA, angle, angle, it equals angle, angle, angle. And so you may figure out from that we're talking about triangles. Okay, so we'll give a quick basis of what we mean right here. We have 2 triangles, and they're similar triangles. Or the same, they're congruent. And so they may not look it, but let's just pretend they are. A, B, and C is angles in one triangle. D, E, F are the angles in another triangle. You see my hash marks here. I'm saying that A is equal to D. Those little hash marks mean that. I'm saying B is equal to E. We know that. We don't know anything about C and F right now, but we'll see what that means. Okay, look up here real quick. We can say that angle A, angle B, angle C, all of those together equal 180. Yeah, we know that. Same thing with D, E, and F. All the angles together equal 180. Now, if everything in here equals 180, everything in here equals 180, then we could say that angle ABC is equal to angle DEF, because they're all equal 180. If all of them equal 180, then together, this is going to equal this. That's just the way that works. Okay, and then now what we can do, we know, remember on an equation, if we have the same value on both sides, we can cancel that value. So A and D are the same. B and E are the same. What does that leave us with? C and F. So C equals F. That's why we say A equal, that means A. Because if we have 2 angles in a triangle that are equal, the third one must be equal. That's just a proof showing how that works. So let's use that a little bit to work on this problem down here. And we'll see our another scale factor problem. I'm sure you love these by now. Okay, so we have congruent triangles, or we have similar triangles. So we have this angle here is equal to this one is equal to this one. If that's the case, then this one, although it's not marked, has to be equal or similar to that one. And so we can see that these triangles are in fact workable. We're able to find out what X and Y are. So let's just use what we've learned in the past. 4SF, the scale factor gets us to 6. So 4SF equals 6. How do I find out what the scale factor is? Well, divide by 4 on both sides. And so when I do that, I can reduce 3 to 2. 3 over 2 is my scale factor. Okay, so now there's something you gotta realize on this one, is that it's flipped. Okay, so notice that the 2 hash marks is on top. Down here, the 2 hash marks is on bottom. And so that means 7 is congruent related to Y and not to X. Although 7's on the bottom here, Y is on the top here, but it's because, again, they're flipped. So what we'll do is we'll say 7 times our scale factor equals Y. 7 times 3 over 2 is 21 over 2. Just multiplying straight across. If we made this a fraction, all right? Same thing works with 5. 5 times our scale factor equals x. That's going to be 15 over 2, because we made a fraction, 15 over 1. Not a whole lot going on there, not anything crazy. We just, what we did right there is learned that if we have triangles with 2 angles that are the same, that means those triangles are similar triangles, or they're the same triangle, or they have a ratio that's going to be proportional to each other. And if that's being the case, when you see problems like this, look for the hash marks and see if one is top and then the other one's on bottom. If that's so, you remember you got to flip it. You got to go from top to bottom, bottom to top. Now the outside ones are always the same, outside to outside. That one's easy to figure out. But the others, you're going to have to use your brain a little bit and figure those out and decide which one goes with X, which one goes with Y. As always, if you have any questions, let me know. I'll be glad to answer those. And again, you put something in the comment, and I'll get back with anybody who has a question, or maybe do some more videos that'll help us a little farther. And we will see you next lesson.